Hi. Hello, and a very warm welcome on this lovely Saturday afternoon in Linz. Welcome to Global Azure 2025. I have the honor that I can present a thing that is very, very close to my heart for the next 45 minutes. It is basically a constantly evolving architecture basis that I apply to a lot of my projects with my customers. First of all, a couple of words about me. My name is Raphael Schwarz. I'm a software architect for 20 years now. I'm traveling through the European IT landscape and trying to support my customers to the best of my knowledge with my architectural input. I'm doing a lot of identity consulting, entity framework and performance optimization consulting as well. And that's basically it. What I'm talking about today is more or less a lessons learned approach to how we structure multi-tenant, large-scale multi-tenant solutions for software as a service providers, basically. And nothing that you will see is a final thing that I would say that's the only approach you can take to multi-tenant applications, but it is what the last 20 years in this business taught me how we can proceed with such kind of applications. The agenda, I will talk a little bit about the theory of what is a multi-tenant application, what do I understand about a multi-tenant application, what are the challenges that I had with my customers designing those solutions. Then we will see a little bit of coding. It's mostly DevOps today, so there is very little code. It's more scripting and biceps templates. And then we will take a look at hopefully take a look at the live demo where we can deploy a whole multi-tenant environment fresh from scratch with our DevOps pipelines right to an Azure environment. So when I'm talking about multi-tenant applications, what exactly do I mean by that? That started a couple of years ago with when a lot of my customers basically deviated away from having a solution that is just installed at one customer and then maintained at that customer's infrastructure to a software as a service approach. So they had to service a lot more customers with their own infrastructure. Most of the times it's Azure infrastructure that they buy, and they have to service a lot of customers and users in that case with the same infrastructure. And the goal for all of my work is basically to make sure that we can use those infrastructure resources as efficiently as possible and keep the system as scalable as possible. So the worst thing that could happen here is that you design a solution that doesn't really scale, and you can service the first 10 customers, you can service maybe the first 15 customers, but then the system is just at its limit and you can no longer extend it. And so that's one of the more important aspects of that design that went behind those scripts and patterns. So multi-tenant for me always in a way means that I have some kind of central managing part of it. So that's the infrastructure part in here. And that would be kind of our master database. So that is the the thing that has all the knowledge about all the users, all the knowledge about all the tenants that we want to serve, and that manages and maintains all those customer-specific databases and elements there. So in all of my projects, it is always the case that we don't have one ginormous database that holds all the data for all of the tenants, because that is just one of those things where you can quickly hit a limit and can no longer exceed what's physically possible in that system. So the design always goes towards trying to separate the customers into separate isolated databases, separated isolated blob storages maybe, and then try to figure out a way so that they can seamlessly switch between those databases if they have access to multiple tenants, for example. The other thought that went behind that separation of the databases and creating a separate, isolated infrastructure part of that design is also that we can have a continuous rollout concept. So I don't want to roll out, if I have 100,000 users in my system, I don't want to roll out one new version of my software to all 100,000 users at the exact same second. Because if there is just a little small bug in there that makes my system 10% slower, 20% slower, I'm in big trouble if that is actually rolled out to every single customer at the same time. In that approach, combined with a hosting approach that we take in the background, we always try to roll out our new versions in small iterations. So we deploy a new version. Let's say we go from 1.0 to 1.1. We deploy the new version. We have a separate parallel backend, front end for that new version. And then we decide selectively which customers, which databases are upgraded to the new version. And so the friendly customers, maybe the customers with the smaller payload in their database get the upgrade first. Then we take a look, does it work? Does it not work? Is there a enormous bug in there that we need to quickly fix? Then at least we only hit one or two customers with that ginormous bug. So the rollout strategy is also a very, very important thing for us. Also, if we are talking about, for example, mobile apps, App Store, I cannot force the exact second where a user gets an app update. So I need to provide a solution for mobile apps, at least, where I can run multiple versions of my software in parallel, at least for the time that I can make sure that all the mobile apps are updated. In the case of an Azure infrastructure, we normally go the route that we have a central master database that handles all the tenant databases. So that system, that infrastructure system, basically creates the tenant databases for me, and it creates it based on a elastic pool in Azure. So it's an elastic SQL Server pool there, and we just simply create databases in that elastic pool. The infrastructure does that, and also the infrastructure updates those databases from that elastic pool. So in this infrastructure administration portal, I have the option to just simply say that customer now gets the update from 1.0 to 1.1, and it seamlessly upgrades the database, because between 1.0 and 1.1, there are no breaking changes in the software. So everyone who's currently working in a 1.0 version of that software can still continue to work as long as his token is valid, as long as he's in the current session. Next time he gets a token refresh, next time he logs in, logs out, he gets redirected to the new version and he gets the new features. But he can still work with the older token, because 1.0, 1.1 are, at least in the database, compatible. So they don't have any breaking changes in there. So that allows us to basically upgrade customers with close to zero downtime most of the times. We do have some situations where we want to introduce some kind of breaking changes. So the major version change from 1.0 to or 1.7 to 2.0, that is a version change where we actually introduce breaking changes to clean up some bad stuff in the database, to just have a window where we can potentially fix that. In that scenario, we basically set a flag in the infrastructure database for that specific tenant, and from that point on, every request that goes to any of those backend servers is validated, and if it's for that specific tenant, it is blocked until the client is updated. So that would be basically, I would, for a mobile app, for example, that would be I have to block that application until he has updated that application from the App Store. On the infrastructure view, it looks a little bit like that diagram. So we have a production environment. That production environment consists of a master environment that exists only once. So that the master database, the master service, also the identity service on top there, only exists once in the production environment. And then we have a number of tenant-specific back-end environments that can coexist. How many of those versions? That depends how many versions of your software you want to support in parallel. Normally, you don't want to support 10 versions of your software. You might want to support 1 or 2 versions in the past, so you get a nice window to upgrade all your clients. In that case, I just painted it with 2 versions in parallel, and those basically 3 separate deployed environments service all of our customers. So we have a number of maybe hundreds or thousands of separate databases behind those infrastructure elements there. And every version backend, version 1.0, serves every customer, basically. So you connect to that v10 endpoint, and the endpoint decides which database you need to take a look at. So that is done with the help of my identity server that is part of the master infrastructure. And every time a user logs in the multi-tenant environment, the user has to select for which tenant he's logging in currently. So every token that I create with the identity server has a specific tenant assigned to that token. So there is 0 chance that someone can log in without having any kind of permission for a database. If he only has permission for 1 tenant, that's easy. He just gets redirected through. If he has permission to multiple tenants, then he gets a selection dialog where he can pick which tenant he wants to log in for. Maybe he can select, that's my standard tenant, don't ask me again, and so on. When creating that token, then I assign the database connection that is associated with that specific tenant to that specific token, and our backends then are able to extract the database connection information from that token and use it in the entity framework to access the database in the background. So that system requires a lot of separate services that I need to deploy in Azure. So I need to have an application insights up and running. I need to have an app service pool. I need to have container services, SQL, Elastic pools, and so on and so on. So. And normally I don't have just one environment at a customer. I at least have a testing environment that is quite similar to my production environment. And in that case, it should be quite similar, maybe less databases, but it should be quite similar and hosted in the same way. Otherwise, it would be a very bad test environment if it differs very much from the production. And also, some smaller environments that maybe don't have the need to have multiple versions hosted, but still they are kind of structured in the same way. A development environment, maybe a specific environment to test a specific bug fix in a close to production scenario, basically. And so in order to do that automatically, I wrote, or I'm starting to write a couple of automated deployment scripts for Azure. And the way to do this currently, I would say, is via Bicep templates. So that's a templating language. Is it a templating language, Rainer? Is it a scripting, or is it a mixture between templating and scripting, basically? Bicep? Yeah.
I would call it a domain-specific language.
Well, that's kind of, yeah. Okay, a domain-specific language. Basically, it's a language designed specifically for deploying resources to Azure in a very, very declarative way, I would say. And that is one of the things I would like to show you right now, is how those Bicep scripts look and what they are currently doing in that environment. Can everyone see everything from back there? Yeah. So in that scenario, I actually created for that specific thing, I created a Bicep script that is basically a wrapper, and that Bicep script creates a resource group and then deploys with a separate subscript, a module, it's called in that case. It deploys the infrastructure part, so all the management parts, and in a separate module, it deploys the tenant-specific parts, so the version-specific parts, basically. Normally, those Bicep scripts are, if you don't change anything, the scope of such a Bicep script is targeting a resource group. So in Azure, resource groups are basically how you aggregate all the resources together. And by default, Bicep scripts are targeting one single resource group. You can change that by simply changing the target scope here. In that case, it just targets the whole subscription. And so I can access a lot more resources outside of the current resource group. In that case, I'm targeting the subscription because I'm creating the resource group in that script. And I'm calling the script that generates my infrastructure. If we take a look at the infrastructure, and that's the more important one here, you see I'm basically setting up all the necessary dependencies that I have for all my app services, all my databases, and so on. So first of all, application insights. The first thing that I create here, I'm creating the SQL Server, then I'm creating the Elastic Pool inside the SQL Server, and so on and so on. And so that's how you specify basically how your resources should look like in Azure. The nice thing here is those scripts can be, they run deterministically, basically. They can be executed as often as you want. It should always create a stable output, or it should create a stable output, basically. If you change anything, if you add another property, if you add another app setting, for example, in the Bicep script, app settings like we have here, for example, the connection string, some other settings, .NET environment, so on and so on. Those settings are added by running that same Bicep script again against the whole resource group again. And here I'm just creating a couple of app services, SQL Server, as I said, and application insights resources, and I'm executing this script by calling it through the Azure CLI. That is a very comprehensive command line interface for interacting with all the Azure resource management functionalities. And here I have a small deploy command line. And that's basically all you need in order to execute such a bicep script against your Azure subscription. You need to call AC login to select which subscription you are on. And then you can just simply call AC stack sub create, then you give it a name, you specify the bicep template, and then you pass in all the arguments, the input arguments for your template. In that case, I'm passing in just a couple of things that I've chosen up front. Things like, for example, what kind of domain I want to use for that environment, what's the name of the container registry that I want to use, and so on. So those are just input arguments for the bicep script. And what I'm doing here is I'm calling AC stack, and what that does in the background is creating a deployment stack in Azure. And that's a very, very nice way to do those kind of jobs, because if you take a look at that specific parameter here, deny settings mode, that's currently set to none, but in a realistic production environment, that would be set to some kind of thing like delete or write. That basically limits every other user what he can do with that specific resource that is created here. Basically, if you set it to delete, then no one is allowed to delete those resources. That includes yourself as well. So if you call that script again and you remove that resource, your script will not be able to remove that resource actually, because it has a lock on it. So you need to at least allow your specific service account to override that specific functionality here. That's what I'm doing here. So what does it look like? Basically, it's just a command line script that I call. It runs through all its paces. You get a JSON as an output with all the resources that are actually created by that script currently. And in the end, what we get is a resource group, or a couple of resource groups in that case, in Azure, that contains all the elements that are specified in the bicep script. Also, you can see in your subscription, if you take a look at the subscription, there is a part deployment stacks, and here you see basically all the resources that has been created with that deployment stack, error messages if it has failed, and so on and so forth. So in that scenario, that helps me very much if I have to create dynamically create multiple environments. So if they want to have a new testing environment, if they want to have an additional staging environment, for example, I'm just executing that thing with a different environment name. That's a parameter that I have. Everything else is done automatically. So I can create completely new environments from scratch, basically. Without any kind of extra effort here. But once that thing is deployed, I still want to get updates into my application, and so that's where we are mostly using currently the Azure Container Registry and app services with Docker containers as a deployment strategy. So we are basically just creating app services and linking them to a container registry, linking them to a specific image with a specific tag, and the Azure environment can automatically create webhooks to that container registry. So every time that image gets an update with that specific tag name, it is automatically pushed to the app services. So all I need to do basically right now is make sure that at the right time, the right image gets that tagging, that specific tagging. And to make that sure, we normally create multi-stage DevOps build pipelines. So we always create images whenever we run a build. We always push them to the Azure Container Registry, but not all of those images are actually really tagged so that they are pushed to a app service. So we always create that image, we push it, and then we have a separate stage where we pull that image again, tag it with the tag that is associated to the app service, and then push that new tag basically. So that's a couple of seconds just afterwards then. And so we can, for example, run stage 1, automatically tag it with a stage 2 for the test environment. So then it's automatically pushed to the test environment. And as soon as everything is tested in the test environment, we can just simply run stage 3, which adds another tag to the same image for the production environment, and then it's pushed automatically to the production environment. And so that's also a thing I want to show you that is working quite well, because those webhooks are very reliable and very fast once they are actually implemented there. And here I have created a multi-stage build script that basically runs. Oh, sorry, didn't see that. Sorry. Yeah. So here, basically, we run the first 2 stages. They run automatically. So we are building all of our projects. In that case, it's the infrastructure project. That's a Docker container that is built here. And that Docker container gets the image tag 100. The publish stage, the first stage that is run automatically, pulls that specific image 100, adds another tag to it, so basically an alias for 100, test latest, and pushes it again. Therefore, it's automatically in the testing environment, because that's how it's set up. The last stage, that is the one that I run manually, so that is configured in the build pipeline, that stage will be triggered manually. When I trigger that stage, I'm doing basically the same thing. I'm getting the exact same image, 100, and then I'm retagging that, in that case, to prod latest and pushing it again, which makes it very easy to roll back a faulty version. So if I'm pushing something that only in production creates some kind of trouble, the only thing I need to do is basically go back to the image that I know is working in production, retag that latest tag to that older version that I know is working, and I immediately have the known good version in my environment. And so the last thing I want to show you is a combination of those 2 approaches, and that is specifically made for, let's say, testers that are kind of not really developers, but they know how to handle a DevOps environment, and that understand how those environments work. Because it very often is the case that we have pull requests that are so big, or they have such an important feature that we want to test that feature in a very close to production environment before we merge that pull request into our main or head branch. Therefore, it would be very nice to just simply click on a button, create a complete test environment in Azure that is set up close to what the production environment is, and then just simply test it and then drop it afterwards. So what I'm doing normally here is I'm creating those deployments. I'm tagging them specifically as temporary deployments, and I run a script once a day at midnight or at 2 in the morning or whenever it seems to be a good day or a good time, and then just cleaning up all the deployments that were not dropped manually. And so that's what that script here actually does. So first of all, I'm doing exactly the same. That's the development environment, basically. I'm creating packages, or I'm creating images, Docker images from my source code. And those images are pushed to the Azure Container Registry. Then I'm running with a manual stage that my tester can trigger. I'm running a bicep script that creates the whole environment. So the infrastructure environment and the tenant-specific environment for that specific version of that pull request or of that feature branch, tags it specifically for that feature branch. And then we have, after, let's say in that case, I think it was about 10 minutes or so. After 10 minutes, we have a complete environment in Azure up and running that is completely identical to the production deployment. And if he's done testing, he just simply runs the third stage here. That's also a Azure CLI script that basically just deletes the deployment stack again that we created here. And so the environment that I'm creating here is, in that case, that's proof of concept currently. I'm not quite sure if it stays that way. Currently, it is based on the branch name that we have here. So there is a feature / then the work item number, and then a descriptive text for it. And currently, I'm just picking the second element here in the branching structure and using that one as an environment identifier, basically. So those packages that are triggered by that specific feature branch, feature 454, they will be tagged, and we should see that here. They will be tagged specifically with a version number. Here we see. They will be specifically tagged with a version number 454.1.2, however often I run that specific build on that feature branch. They will be tagged specifically as 454, and the environment that is created also listens with the webhook to 454. So once the environment is created, even if someone changes anything, pushes it to the pull request again, it will be updated automatically, because that temporary 454 environment is still present. And when I'm finished, I'm just dropping the whole deployment stack again. And yeah, that's basically it. I don't know how much time I have for that. Nothing.
10 minutes.
10 minutes. Yep. Okay. Then that should be exactly enough to trigger such a build, such a specific environment here, the 454 environment. And in parallel, I can take some questions if there are one. And I'm just triggering that build right now with a small minor change that I make to the application. Let's say, for example, instead of hello, I'm writing here message from feature branch. Then I'm pushing that thing to feature 454. Message commit push. So now we should see this build script. The first stage should be quite fast because that's just creating a couple of Docker containers and pushing them to the registry. That's not very complicated. I think it's 3 or 4 minutes. It should be done. And then when I click on the first stage, that is actually the stage that really creates or runs the bicep script for that 454 environment. And in parallel, we can take a look at the Azure portal and our resource groups. So currently, I do have a 1-0 production deployed. So that's basically the 1.0 version of the tenant-specific services. I have the production, that's the infrastructure for production, and I have the dev system deployed. So the dev system is the one system that contains infrastructure and the actual version, because it's always just one version. So it's the dev thing. And when we run the stage 1 afterwards, we should get another resource group that is basically the same as the dev version, but just simply with the environment tag 454. So let's see how far our build is. Yeah, should be done shortly. The second build is very quick because that's just the identity server, and Angular build I think takes a little bit. But yeah, that would be the ideal place now. If there are questions, I would answer them right now in parallel until that script is done. Please.
How do you keep the infrastructure of the different environments up to date? Do you change the things?
It's always latest version. That's always latest version. So
I mean the things that are in the bicep script, for example, you have to change anything in the database cluster or something.
Yeah.
How do you update the
changing the script and deploying it?
And so it updates then the
exactly.
So
exactly. I mean, Anna, you know it better than me. How well does it work in biceps if you have really finely structured changes, the differences between the production and the script that you want to have?
Very well. There are only a few settings which cannot be changed, and they are super specific for some auth related stuff or networking stuff, but they are not really an issue in real life.
As far as I've seen so far, it kind of seems to work that you really enable that deny delete policy, so that your whole truth is actually the script, and you only deploy with that script.
That was the question, because in the GitOps Vienna,
yeah.
For example, you could automatically trigger the bicep update
yeah.
when you change something in the GitOps, for
yeah.
example.
Yeah. Yeah. That's definitely. I would say that's definitely the way to go. I mean, we have the best Azure consultants of Austria here. So
I think you will not run into a problem. For those of you who listened very closely, reference said he's using deployment stacks. I would like to point that out again. So don't just look at bicep, but only recognize that he's using deployment stacks. That's something specific, not just running bicep.
Yeah, when it comes to the delta detection, yeah.
Sorry.
Sorry.
Regarding the deploying the health packages Kubernetes.
Yeah.
Can we use the same template for the bicep to be the same? Because here I can see only the build and pushing the data.
I'm not quite sure because I'm pushing Docker containers to app services, basically. Yeah. If it's a managed service from Azure, you can do everything with bicep, as far as I know, what it could do technically in the UI.
Yeah,
theoretically.
you can run scripts in
Yeah.
Bicep, so you can run any kubectl scripts that you would like.
So the first stage is completed. So that basically just created the images in the container registry. So the images are already there, and only if I actually really want a testing environment for that feature branch, I'm running stage 2, and that now is actually deploying things to Azure. So that should now shortly create a new resource group here with the with the suffix 454.
May I ask a question?
Yeah.
You're a great expert when it comes to EF and databases and so on. Can you spend a minute or so talking about how you handle databases, test databases, migrations, and things like that?
I mean, that's I could talk 2 hours about that, but in general, in that environment, basically, I'm using in general for the customer databases and for the production environment, I'm using regular migrations. So basically, the central infrastructure system triggers migrations from the actual target database. So basically, when I'm updating a database from one customer, I'm basically updating the version flag in my master database and then specifically calling the version 1.2 that I want to migrate to, the services from that specific version to update that database. So that the central infrastructure calls into a specific version to update a database to a specific point. The dev scenario here that's a little bit different, because that is where I normally add some kind of extensions into the web services, so that I can have kind of database initializers that can create deterministic versions of the database for the integration tests, basically. So what I normally have is some kind of code that takes some data that is deterministic from JSONs, from Excels, from whatever we get as a source, or we generate it. So there's a lot of customers where we really actually wrote data generators in C# that just creates a whole load of data in a deterministic way. And so the testers always know what to expect. So they create a new testing environment, and normally they get a button where they can initialize that database to a specific set of data that they know how to test against. So the testing plans are written against basically that sets of data that we have normally.
Thank you.
So let's see if we can wait for that deployment. I mean, it is running for 3 minutes now. It tends to be a little bit faster when you run it in the DevOps pipeline compared to the local.
Yeah. Sorry, one question. So what triggers the migration itself? And is it the app service which does migrate database, or is it a pipeline that causes?
No, not the pipeline. I mean the migration for the central master database, that is triggered automatically. As soon as it's deployed, the central master database is always updated to the latest version from the infrastructure part. But the tenant databases, that one is triggered manually, and it depends which customer it is. Some of my customers, they don't want the users to decide when they want to update, so they want to force the update on a specific day. So in that case, they built a let's say a maintenance portal where only their service employees can access and update that specific customer. Some of my customers, they just say, okay, well, there's the option. They get a time window from, let's say, now to in 3 months, and in that time window, they have to update that thing, otherwise it will be done automatically. But normally they give the customer a kind of a window, let's say 2 to 3 months, where they can update the database by themselves, so they can pick whatever is the best time for them to update, and then they update. Otherwise, at the end of those 3 months, it's forced, and then it's just automatically executed. But it is a manual process. At least in the beginning, it is always a manual process, because we just want to see if it's working, the new version, and so on. Yeah.
How do you hold the migration? Then, like in the bundles, or how do you like initiate the migration when it's done manually? How is the migration?
That was the thing that maybe I didn't explain it right. Every version that I have, every version environment that I have, version 1.0, version 1.1, has a specific API, a specific set of APIs, and that is very stable. So that API basically never changes. But that's very rudimentary. That's very, very small set of calls that I can make against that specific version. And one of the calls that I can make is, please update the database. So by deciding which backend I'm calling from the infrastructure, so that is a service that can only be called from the infrastructure. So only my infrastructure environment is powerful enough to generate a token that will be accepted by that endpoint, by that migration endpoint. Only my infrastructure can send that token. And it basically just sends an information to that specific version with the database that is associated with the customer. The connection string is part of that token. It sends the information and says, please update. So it calls just simply entity framework.migrate, basically. And that can take a little while. So it's an asynchronous process. So when you call that thing, you give a callback URL where the system then calls back when it is completed or when there was an error, basically. Yeah. So, that is very good. We are completed. So I'm 3 minutes over. I hope we can see that at least. Right now, we should have a new resource group, exactly 454. That thing I have to do manually right now because I have a bug in my bicep scripts. There is one thing that isn't done automatically right now, and that's the webhook is not added automatically right now. And so I have to quickly switch continuous deployment off and on again, and only then the infrastructure will start. But that's just one line in my bicep script that I messed up basically. So that happens when you try to change your samples half an hour before the demo. So yeah, I just have to click 3 times on that button. It's only quite fast. That error message came before. That doesn't really matter, seems to. And in that case, we actually do have a nice URLs as well, because I'm just using a DNS zone that is managed by Azure directly. So basically, by creating that dynamic environment, I'm just simply automatically creating subdomains for that specific domain, because everything is managed by Azure. It is all it is able to do everything for me, basically. So after saving that last entry here, I should be able to access login 454.coderp.com. That's the managed domain that I've added there. And of course, it didn't work. No. That is exactly the issue that I have when the deployment slot is not working.
We trust you.
I don't trust him. But at least you see that there is a new URL where the application answers to. So basically, I'm just deploying all the 3 app services that I have to that subdomain 454. So it's basically login, web, API, and that's where I deploy it to. And as I said, normally if the continuous integration works well, I should get a pretty quickly up and running application there as well. In my tests at home, it ran quite well after 10 minutes. So it was creating the new environment. Yeah, now it runs. Swagger.
Yeah.
And so that's actually really a new database because I have to change my password.
Amazing, Raphael. Thank you very much. I think you are hanging around a little bit more. We ran a little bit over, so let's say 5 additional minutes. I will ask my colleague in the other room to also start 5 minutes late. So grab a last drink. Maybe, I don't know if there are still